Greetings, everyone. I am going to record now a review of my notes on causal reasoning. And I recently updated them. I revised them a little bit. It's not radically different from what was there before. I think it's a little bit better organized. And I've posted them both to Canvas and to my website. And so if you go there now, that's what you'll have access to. And then I was going to actually create a new PowerPoint presentation and record a video lecture going through the PowerPoint presentation. But all I ever do is actually cut and paste my notes into the PowerPoint. Perhaps you've noticed that already. And so I'm thinking probably the last thing in the world the students want is for me to take, I don't know, an hour to read through notes that they have access to already. So what I'm going to do instead is I'm going to go to my web notes that you have access to. I'll highlight some of the things I take to be important, and then you are welcome to contact me if you have questions or there are other things you want to go over. But if after my walking you through the notes and you reviewing them on your own, you're fine, well, then we're good. And you don't need my lame PowerPoints, all right? So, and I'm going to try and keep this short because I understand that my lectures are a little long, and we'll try and keep it at a minimum. So let me share my screen. And what screen do I want to share? Oh dear. Is this it? Well, we can try. No, not really. Hold on. No. This isn't working out. Hold on. Oh, here, let's do this. My homepage. Critical thinking. Notes. Causal reasoning. There we are. Okay. Oh, and maybe I'll try and increase the size of this a little bit. All right. All right, so this module is on causal reasoning, and what are the means by which we construct causal arguments. We try to establish what the cause of a particular effect might be, etc. And as I was reviewing these notes, I'm thinking, oh, there's so much more you could say, but I didn't add too much to what was already there. But there is, this is in philosophy, the very notion of what is causation, on what grounds do we have to posit one event as causing another event, etc. This has a very long, rich history within philosophy and in metaphysics and in philosophy of science, but that's not what this presentation is going to concern itself with, right? So we're going to really just talk about causal reasoning as we encounter it in a daily basis in our regular affairs, and we won't necessarily treat it as a topic of deep philosophical concern at the moment, but it is, and I'd love to talk with you about it later if you want to, but not for this presentation. So initially, I'm simply making a distinction between causal statements and causal arguments, right? So causal statement is simply where I state boldly such and such is the cause of that, right? I don't know, the cause of his flu-like symptoms is the COVID-19 virus, right? Or something like that. Or here I'm saying the floor is wet because the toilet is leaking, and therefore I'm claiming that the leaking toilet is the cause of the wet floor. Alternatively, I might say because the toilet is leaking, the floor is wet, or because he has COVID-19, he has flu-like symptoms, or something like that. Right? So there are two words you want to be familiar with, the explanandum and the explanans. And the one is that which is being explained, and the other is the purported explanation, right? So in literature on causal reasoning, they use these terms. That's why I felt the need to introduce them as well. And I don't necessarily use it all the time, but I may. So I want you to be familiar with those terms, right? Who knows? It might make its way onto a multiple choice question, okay? A causal argument, by contrast, is an attempt to persuade you to believe that such and such is the cause. So if I'm merely making a bold statement, that is the cause, well, that's not an argument, it's just a statement, right? And you might ask me, why should I believe you? Okay, then I'd have to give you an argument. But I may preemptively actually provide you with an argument. And I can say, I know that the toilet is leaking because the floor is wet. Now, again, this too is a single statement, but it differs from the first in that I am offering a conclusion that the toilet is leaking, and based on evidence, the best evidence I'm giving for that is the wet floor. And the best explanation for that wet floor I'm suggesting is the leaking toilet, which is why I conclude that the toilet is in fact leaking, right? So thus, it invites us to infer and explans from the explanandum. I have to explain why the floor is wet, and the best explanation for that is the leaking toilet. All right, so that's pretty clear. Establishing the truth of causal statements, right? Well, here's an example of an argument. I'd say, well, we turned the toilet off and dried the floor and waited and everything stayed dry. And then later we turned the water back onto the toilet and waited and a puddle developed, right? So this is convincing evidence that the leaking toilet is what's causing the puddle, it's what's causing the wet floor, right? So that's an example. I mean, not a particularly breathtaking example of a causal argument. But let's talk about forming causal hypotheses. First of all, forming a hypothesis is one thing, confirming a hypothesis is another. So these are distinct activities. And so in any kind of causal reasoning, you're going to enter into both phases. You're going to have to dream up a possible explanation and then try to confirm that explanation. Now, this is clearly something that Karl Popper talks about. I think we referenced Popper earlier when we were looking at relativism and absolutism in scientific theory, and we were talking about Thomas Kuhn as being a response to Karl Popper. Both of them were doing philosophy of science. But Popper suggests that there is the context of discovery and the context of justification. And these roughly coincide with forming a hypothesis, context of discovery, which he thinks is rich and imaginative, and it is not formulaic. You can't sort of sit down and formulaic dream up a hypothesis. It requires a kind of creative insight. But then the second half, the context of justification, is a confirming process, and that can be rather predictable. Right? For Popper, remember, he thought it was the process of attempting to falsify. So you set up experiments such that they would falsify your theory. And if the theory resists falsification, no matter how often you test it, then it starts to gain in credence. And then we have reason to think that that theory might be true. Recall that Popper famously points out you can never fully confirm a thesis. You can only falsify a thesis. But that's how science works. For our purposes, that's probably more detail than we need, but just keep in mind that there are two processes that go into causal reasoning: the forming of the hypothesis and then the confirming or testing of the hypothesis. So I'm going to skip ahead here. You can go back over this some more if you like. So let's go back to this idea. For one, we have to decide what is it that needs to be explained. So remember, early on in our course, we talked about crucial to clear thinking, critical thinking, is establishing precisely and as carefully and as unambiguously as possible what the issue is, what is at issue. And in this case, that corresponds to establishing what precisely are we trying to explain. So in this case, the car won't start, right? All right, so why won't the car start? What is the best explanation? What is a reasonable explanation for this? Well, now we have to engage in the hypothesizing. We have to consider possible explanations. So form our hypothesis of the most likely candidates for what explains it. And so how do we do this? Well, there's a couple of ways you go about it, right? So one is the pairing of unusual events principle. So if the car won't start, and this is a new unusual event, I mean, if the car never started, then maybe it isn't that much that needs to be explained. But if the car normally starts and now it won't, well, that's an unusual event. Well, are there other unusual events that have occurred around that same time? If so, then those form possible hypotheses as to why the car won't start, what explains the car won't start. So for instance, if I am hearing a weird clicking sound that I normally don't hear when I turn the key in the ignition, well, that's an unusual event that might be tied to the car that won't start, maybe a dead battery or something like that. Or if I smell gasoline, and I don't normally smell gasoline when I'm in that car, but now I do, ooh, perhaps I have a flooded engine, and maybe that's why it won't start. So again, you're trying to see, are there unusual events? I have the event here of, let's say that I wake up one morning with a splitting headache, and that's unusual for me. I normally don't get splitting headaches. Well, then I try to think, well, did something unusual happen? That maybe I had a little too much to drink last night, or maybe I slept with my neck in the wrong position, or maybe, so again, I'm trying to see, is there another unusual event that might be the explanation for why I'm having this unusual event. So anyway, that's one way of forming a causal hypothesis, pairing unusual events, okay? A second, whoops, where's the second one? Oh, that's A, right? Okay, so now I'm looking for B. Here we are, forming causal hypothesis and the common variable principle. So basically the idea here is if there's a common variable to the events being examined, the events that need to be explained, then that becomes a possible hypothesis, right? So for instance, let's say several people at the Kearney, the town of Kearney, you imagine, start complaining and going to emergency rooms or their doctors complaining of intestinal distress. And so that's an unusual event, right? It isn't typical that these Kearney residents might be doing this. But we also noticed that each one of these individuals had recently eaten tacos at the state fair, right? Well, if we have two variables, these individuals are sick and these individuals also ate tacos at the state fair, now we have a possible explanation. Perhaps the tacos themselves are the cause of the disease, right? So why consider this? Well, because each of the instances of the residents experiencing these intestinal distress was preceded by an instance of that same resident eating tacos at the county fair. So this is a covariance, right? It would even be more strengthened if it turned out that no one who failed to eat a taco showed these symptoms, right? So that gets actually into the next principle, which we'll talk about in a moment. But clearly, we have a hypothesis to go on if we have these covariants. The variable of having the intestinal distress is coordinated and collated with individuals who had eaten tacos, right? So the next one is a double covariance, right? So think of it this way. If only individuals who ate tacos are the ones who experienced the distress, and no one who ate tacos failed to exhibit the symptoms, right? So it seems like it's necessary and sufficient, right? No one had those symptoms who failed to eat the tacos, and everyone who ate the tacos did have it. So you have a covariance on both. Or maybe it's not each and every one, but greatly, right? So the higher the covariance, even stronger suggesting the causal argument. It strengthens the causal argument, right? So notice, if some people ate the tacos, but they didn't get sick, or some people got sick that never ate the tacos, well, that would weaken the causal inference. It wouldn't absolutely eliminate it, but it would weaken the causal inference. So the stronger the covariance, the stronger the inference, the weaker the covariance, the weaker the inference, right? All right, so, and I talk more about that there. We have to be careful of what's called correlation due to common cause. This is actually a fallacy within causal reasoning, if we don't consider this, right? The classic example is this. Individuals who have nicotine-stained fingers often have a higher risk or show greater rates of lung cancer. And so you might think, oh, well, then the nicotine-stained fingers is causing the lung cancer. Well, no, actually, there's a better explanation. The better explanation is there is a common cause for both the nicotine-stained fingers and the lung cancer, and that is smoking cigars. And so we say there is a correlation, and a high correlation, to the stained fingers and the increased instances of lung cancer. So there's a high correlation, but the correlation isn't explained by a causal connection between these two events. The correlation is better explained by a common cause for both set of events. Again, the smoking of cigars. So when there is a high degree of correlation, one of the things that you need to look for is there possibly an antecedent common cause to both sets of events? There's a similar fallacy with respect to causal reasoning that you have to be careful of, which is reversing cause and effect, right? So you might say, oh, it's the lung cancer which causes the staining of the fingers. Well, no, that's to reverse the cause and the effect. In this case, that's a bad example because that wasn't cause and effect. But let's say that I notice that when crime rises in a particular a region, let's say a city, gun sales also rise in that city. And I might say, aha, the rising gun sales is causing the rise in crime rates. Well, that's possible, but another possible explanation is the rising crime rates is what's causing the rise in gun sales. In other words, people feel unsafe, and now they're motivated to go out and purchase guns when previously they weren't. So you have to be careful not to reverse the cause and effect. Maybe the crime rates cause the rise in gun rates, or perhaps maybe the rising purchasing of guns is resulting in more crime. But you can't tell just from the coordination, and to do so, to leap to that, is a fallacy, and it's potentially the fallacy of swapping out cause with effect. Confirming a causal hypothesis. The main point of this little section is I'm talking about a particular phrase called "but for which," and the Latin for that is conditio sine qua non, right? A condition without which not. That's actually a term that's used in law, the Latin, and also the English phrase, but for which, right? And the idea is this is stating a necessary condition for that which is being explained. If that didn't happen, if A didn't happen, B would not have happened, right? B would not have happened, but for which, right? If A hadn't occurred as well. So this is important when establishing things like responsibility, particularly in cases of law or even insurance responsibility, right? So notice, back to my toilet leaking example, you might say, well, when we turned off the water to the toilet and dried the floor, the leak stopped and didn't recur. And it didn't recur but for turning on the water back to the toilet. Therefore, but for the water flowing to the toilet, there wouldn't have been a leak on the bathroom floor, and therefore the leaking toilet is the cause, right? So I'm not being particularly clear about this. Hopefully my notes are clearer, but you get the idea, right? So that's the impetus behind the causal argument, and it's fine as far as it goes. But a critic might complain that the toilet would not have been leaking but for the fact that there was water in the toilet. And there wouldn't be water in the toilet if there wasn't water on Earth. And there wouldn't be water on Earth if the Earth wasn't just the right distance from the sun. And the Earth wouldn't be just the right distance of the sun if the universal constants of gravitation were such and such, right? So we might have this long trail of things that had to be the case in order for there to be water on the bathroom floor. And I say, oh, well, all of these are the cause or figure into a causal story of the water on the bathroom floor. There's a sense in which that's actually true. There's a sense in which where we begin our causal story is fluid. I won't say it's arbitrary, but it's not clearly fixed. Maybe I start by talking about the Big Bang, or maybe I start talking about the water flowing into the toilet from the pipes, right? The question is has to be sharpened as to, again, what is that issue? What is it that I'm trying to explain? And that may narrow our focus. So we don't have to talk about the Earth's distance from the sun or the fact that there's water on Earth, right? And that doesn't properly figure into explaining the cause. Is it related? Yes, there's no way to say it's not related, but it's not relevant to our practical aim in establishing how can we stop this leak from recurring, right? And we don't have to do anything about the distance of the Earth from the sun, and we don't have to do anything about the universal constants of gravity in order to get this a leak fixed, right? So that's usually what has to guide the framing of our causal argument. Now, in law and in insurance, this is often taken as what's called the last proximate cause. So they make the distinction between the cause in fact, which is the but for event. But for their water being in the toilet, it wouldn't have leaked. But again, but for the Earth being just the right distance from the sun, there wouldn't be water on the floor, water on the Earth. Those are both but for. They are necessary. So that's a cause in fact, but they're not necessarily relevant to establishing what we want to establish here. So for law, they have this second criterion, which is proximate or legal cause, right? And so passing the but-for test shows it to be a cause, but doesn't show it to be a relevant cause to the case under discussion. To that, you have to talk about, was that cause that you're referencing close enough in the chain of events to make it relevant to what it is you're trying to describe? So I'll just read briefly from my paragraph here. Therefore, the second test, right, the proximate cause, is used to determine if a certain cause in fact is close enough to the harm in the chain of events to be legally valid. The test is called the proximate cause. Proximate cause is a key principle in law and matters of insurance, and is concerned with how the loss or damage actually occurred, right? So again, it's fixed by the practical concern of the case under consideration. What is the issue to be explained? What is the event to be explained? In law, there are several competing theories as to what goes into establishing proximate cause, and we don't need to go into the details of that. Actually, it's rather controversial and a little bit challenging, but just recognize that there has to be some sort of narrowing of what we are considering when we're trying to explain the cause of the event. And this narrowing often is looking at, well, what was the most recent or the most effective cause, right? And then weighing of evidence, okay, we've talked about that already, but you can go through it a little bit further. Randomized controlled experiments would again just be cases of where you're trying to falsify, and where a theory resists falsification, you have reason to think that that theory is true, but it doesn't necessarily confirm the theory. It just shows it hasn't been falsified yet. Popper claimed that scientific theories are always in the process of being falsified, although they aren't always falsified. Here's just different types of causal arguments. This is just a typography, right? So there's a particular case, confirming a particular case, disconfirming a particular case, confirming a set of cases, or disconfirming a set of cases. That's really all that breaks down to. And evaluation of causal arguments, causal fallacies. We discussed these already in some. Oh, and then the last thing, I just thought I'd give you some links on a differential diagnosis. This is something that's literally done in medicine. I don't know if any of you plan on going off to medical school or whatnot, but they talk about trying to come up with what? A causal argument, right? So you're trying to establish what the cause of the disease or the infirmity under consideration is, and how might you start building your hypothesis and building your case and ultimately reasoning to what you believe to be the cause at issue here, and you develop a differential diagnosis, and here are the steps of that, okay? Maybe I'll skip to the summary. What do I say in the summary? No, never mind. Oh, I just thought this was interesting though, right? Popper had suggested, back to Karl Popper, and this is my last word on Popper for this presentation, but Popper had suggested that science actually proceeds when scientists entertain bold hypotheses, and not just sort of derivative hypotheses. Because even in the disconfirmation of a bold hypothesis, knowledge is gained. But there's a difference between that bold hypothesis that Popper is talking about and the kinds of causal arguments that normally confront us on a daily basis in law or insurance or in medicine, or just trying to figure out why the car won't start, right? So, if I'm trying to figure out why the car won't start, a bold hypothesis might be aliens from another planet are putting a dampening field on my car and beaming it down from their spaceship, which is in orbit or something like that. Yes, that's a bold hypothesis, but that's kind of a silly, fanciful, wild goose chase that I wouldn't seriously entertain, nor should I, right? So here's my paragraph on this. However, it's important that the doctor not start with too many fanciful possible hypotheses, but start from the most likely contenders. This is not only to conserve energy and resources, but also time. It's very possible that the condition needs to be addressed promptly. Too much time spent eliminating wild goose chases is not in the interest of the patient. Nevertheless, that is why this is an art rather than a formulaic process, which sometimes requires hunches and intuitions. Still, it remains the sort of process of elimination, which the last man standing is the likely cause of the symptoms. This again can be an instance of inference to the best explanation. Of course, famously, Sherlock Holmes claims, when you have eliminated the impossible, whatever remains, however improbable, must be the truth, right? But there's another saying within medicine, I think I mentioned it earlier in the notes, which is, if you hear hooves, think horses, not zebras, right? Why? Well, because it's much more likely that the sound of hooves would be produced by horses than zebras. Now, of course, that's true in the United States. Maybe that wouldn't be the case in Africa, right? But in any case, all right. So hopefully this little walkthrough is helpful to you. If questions arise or something doesn't make sense, by all means, please let me know, contact me. I'd be happy to clarify it for you and maybe for the rest of the students in the class. And that concludes my remarks for today.